Hey guys, it's the last section of Chapter 1. We're going to be doing absolute value equations and inequalities. So we're going to be taking what we learned in lessons 4 and 5 and adding absolute values to it as well. So our essential question is, what steps must be followed to solve equations, specifically with absolute values? So we're going to write and solve equations using absolute values and also inequalities. So an absolute value is a real number that's written in these two brackets that are just kind of straight lines. Basically, it's just the distance from 0 on a number line. That's all an absolute value means, is its distance from 0. And an extraneous solution is a solution that's derived when you solve an equation, but when you actually try and use it, it does not solve the equation. You're going to have a lot of these when you have absolute values, so we're going to be checking our answers a lot. Alright, so let's go ahead and start. We're going to start with the easy ones, the equations. So what's the solution of the absolute value of 2x minus 1 equals 5? Okay, so for these, if I just told you the absolute value of 5, what would you say that is? 5, right? What if I told you the absolute value of negative 5? They're both equal to 5, aren't they? Okay, so what we're going to do is we're going to have two separate answers. We're going to have a positive and a negative solution. So in order to get rid of these absolute values, you leave what's inside the absolute value the same, 2x minus 1. You set it equal to your original problem, and then you also set it equal to the opposite of your original problem. So we have a 5 and a negative 5. We're going to solve each one of these equations. So 2x equals 6, x equals 3. 2x equals negative 4, x equals negative 2. So I have two possible solutions. I have 3 and negative 2. Now what we have to do is we have to check both of these to make sure that they work. And we have to go back to our original, 2 times 3 minus 1, take the absolute value of that. Does that equal 5? Well, 2 times 3 is 6, and 6 minus 1 is 5. Absolute value of 5 is 5, so 5 equals 5. So good. So 3 is a solution. Okay, now we have to try negative 2. So the absolute value of 2 times negative 2 minus 1 equals 5. Well, 2 times negative 2 is negative 4, and negative 4 minus 1 is negative 5. Absolute value of negative 5 is positive 5. So we get 5 equals 5. So these are both solutions. So our solutions are x equals 3 and negative 2. Oh, and we're supposed to graph them. So here we go. 3, negative 2. For these, since it's equal, you just make 2 circles. That's it. It means of all the numbers in the world, 2 of them fit. Okay, so I want you to go ahead and try this one. Alright, so when you set up these equations, you should have 3x plus 2 equals 4. 3x plus 2 equals negative 4. That'll give you your, get rid of your absolute values, give you your two possible solutions. Okay, and then when you solve them, if you keep going, you get that x equals 2/3. So it'll be 2 of the 3 ways to 1, and negative 2. And there's your answers. Oh, double check, make sure they both work. And they do. Alright, so multi-step. So in this one, remember our goal in solving equations is always to get the variable by itself? Well, in these we're going to start by getting the absolute value by itself. So we want this part by itself. So right now, most closely related to the absolute value is the 3, so we're going to get rid of the negative 1. Do that by adding 1 to both sides. So 3, absolute value of x plus 2, equals 9. Now in order to get the absolute value by itself, we need to divide by 3. So absolute value of x plus 2 equals 3. Now we can get rid of the absolute values by setting up our two separate equations. subtract 2 from both sides. To get x equals 1, x equals negative 5. So again, you need to make sure you go back and check and make sure that your solutions work. So let's see, 3 times 1 plus 2 minus 1, does that equal 8? Let's see, so I have 3 times the absolute value of 3, so that's 9 minus 1, yes, that equals 8. Okay, and then negative 5, I have 3 times negative 5 plus 2 minus 1, does that equal 8? So I have 3 times the absolute value of negative 3, which is positive 9 minus 1, which is 8. So again, both answers work. 1 and negative 5 are both our solutions. Okay, go ahead and pause the video. I want you to try this one. Alright, so when you solve, you get x equals negative 7, negative 11. If you try them both, they work, so they're both solutions. Alright, now here we're going to start having extraneous solutions. So we're going to solve these just like we did the other ones, except some answers are not going to be acceptable answers when we try them. Okay, so we don't have anything to get rid of with the absolute values. So we're just going to go ahead and set up our two separate equations. So get rid of the absolute values. 3x plus 2 equals 4x plus 5. And 3x plus 2 equals the opposite of the whole thing, 4x plus 5. So that means we're going to have a negative 4x minus 5. Okay, so I'm going to subtract 3x from both sides. Subtract 5. So I get negative 3 equals x. And then this one, this is going to be negative 4x minus 5. So I'm going to add 4x and subtract 2. So I have 7x equals negative 7, x equals negative 1. Now we're going to try both of those. So 3, absolute value of 3 times negative 3 plus 2, will that equal 4 times negative 3 plus 5? See, this is negative 9 plus 2 is negative 7, so that's 7. Let's see, this is negative 12 plus 5 is negative 7. Positive 7 and negative 7 do not equal each other, so that's not good. Let's try this negative 1. 3 times negative 1 plus 2. Is that equal to 4 times negative 1 plus 5? See, so this is negative 3 plus 1 is negative 1. Absolute value of negative 1 is 1. So I have negative 4 plus 5, which is positive 1. 1 does equal 1, so that means we only have one solution. And our one solution is x equals negative 1. Negative 3 was not a solution. So make sure you are checking these. Alright, and then with the inequalities, the same rules are going to apply. When you change your sign, you're also going to have to change your inequality sign too. So your book kind of does it as a one-step process. I'm going to go ahead and show you as a two-step process. So your first equation is going to look the exact same. 2x minus 1 is less than 5. Now, when you change your sign on your 5, you're also going to change your inequality sign. 2x minus 1 is greater than negative 5. And then we're going to solve each one of these individually. So 2x is less than 6. X is less than 3. 2x is greater than negative 4. X is greater than negative 2. Okay, make sure again you are checking both of these answers. Oops, didn't mean to do that. Stop. I want that one. Why, where'd it go? If you wanted to, you could also do it like the book does. What they go ahead and do is they take that positive 5 and they move it to the back of the equation and make another inequality sign. Can you see how if you just looked this direction, 2x minus 1 is greater than negative 5 looks just the same as what we did? It does, because it means the same thing. And then what you do is you take and you just, what you do to one part, you do to all the parts. So you would add 1 to each part, divide each part by 2. You still get the same answer. And then when we graph it on a number line, let's see, I have 0, 1, 2, 3. Okay, so x is greater than negative 2, non-inclusive. X is less than 3, non-inclusive. So this is going to be what kind of problem? It's an AND problem. Compound inequalities. They're awesome. Okay, I want you to go ahead and pause and try this one. Alright, and then here's your solution for that one. If you set it up, make sure you change signs, change all signs when you do absolute values. But leave whatever is inside the absolute value alone. Do not change that sign. Alright, so this is basically the same thing. You're going to change sign, but when it's a greater than or equal to, you're going to have to do two separate equations. So just solve like we normally would. Subtract 4 from each side. Divide 2 from each side. So I get x is greater than or equal to 1, x is less than or equal to negative 5. Now we're going to go ahead and graph those on a number line. 0. Okay, they're both closed circles. Greater than 1, less than negative 5. What kind of problem is this one? It's an OR problem. Okay, so greater than or equal to is an OR, less than or equal to is an AND. Okay, one last one. See what you got. Alright, and here's your solution to that one. Check your work, make sure you got it right. It should look lovely. Okay, and for review, go ahead and, this is your lesson check. Go ahead and answer these 4 questions, have them ready to compare with your partner, and I'll see you in the morning. Don't forget to work on your homework.